I'm Ethan Kwan, and today I'm going to be showing you how to classify these numbers on your screen right now. So, what are the classifying numbers chart? Well, so let me do the first color in, let's say, this color. So what we have, and let me just change brushes. This color. Okay. Yep, that's good. Okay, so what we have is first we have all the real numbers. So you know what, that's a bit too big. Okay, so these are all the real numbers. These are all the real numbers. That's what I said. Oops. Okay, there. And in those real numbers, so this is like the normal average numbers you might deal with all day, like 2 or 17 or 1,000,001, or maybe like if you know up to like or 43 quintillion, all the combination, which are all the combinations in a 3x3 Rubik's Cube, or few, or 1,000. 10,000, 100,000, those kind of numbers, that's what I mean. So, 500, stuff like that. So, oh, and 1, 0.1, 0.01, and these are called the rational numbers. So there's also another class called the irrational numbers. What are these irrational numbers? Well, they are real numbers, but still. So, I'm just going to explain that after, but there's another class outside of real numbers called the, okay, this seems, oh well, whatever. This is another class called the imaginary numbers, and you probably haven't heard these yet, but these are not a part of real numbers. They are called imaginary numbers, and you cannot write them down. Well, you can, but still. So though I'm not going to write the names, but this is the imaginary. Let me just make an I for that. And this is the real. Let me just make an R for that. Oh, I should do it in the same color. Just find that color. R. Okay, real and imaginary. Okay, so in these real numbers, there's something called rational numbers, which I'll do in pink. So, rational, okay, maybe that's a bit too small. Rational numbers, I'll just do this, RA, so it doesn't get mixed up with real numbers. So, R, A, and the the irrational numbers, IR. That's what I'm going to do. So maybe this can be in purple. Irrational. And in these rational numbers right here, there are the integers. So what rational numbers are? So rational numbers are any number can be written by adding dividing one integer by another. So for example, 1/2, which equals 0.5, -7, which equals -7/1, 4.12, which equals 412 100ths, 1/3, which equals 0.3 repeating, and so on, like 0.25, which equals 1/4, and stuff like that. So those are the rational numbers. Now there are the integers. So let me just do that in this blue color. So inside these rational numbers, there are integers. So all these integers are rational numbers. All these rational numbers, not all of them are integers. That's IN. I'll write that in IN, integers. Okay, and in those integers, there is something called whole numbers. I'll do that in the W and yellow. Okay, so they're the, okay, maybe that's a bit too small. whole numbers. So W whole. And then in these whole numbers, there is another class called the natural numbers. So I'll do that in an N color. I mean N. Okay, so all the natural, so let me start from the inside. The natural numbers, well, yeah, so all the rational numbers are any number that can be written by dividing one integer by another, like 1/2, 1/4, stuff like that. Now, integers are all whole numbers, so 1, 2, 3, 4, 5, 6, 7, 8, and below 0, 0, -1, -2, -3, and so on. So, and then there is the whole numbers, which start at 0 and go up. So 0, 1, 2, 3, 4, and so on. And the natural numbers are counting from 1 and up. So first, let's classify these. So first of all, 2. So 2. You know what? Let me classify these in this. I'll classify them in this dark blue color. Okay, so now, 2, it is a rational number because it can be expressed as 2 over 1. So it's a rational number. So a rational number, yeah, it's a real number, obviously. So it's a real number and it's a rational number. And it's not done there. It's an integer because it's another whole number. I mean, like, it's an integer because it's 1, 2, 3, 4, 5, right? And it's a whole number because it's a number with no fractional or decimal part. It's also a natural number. So it goes in all the way in here. 2. Okay, maybe that's a bit too, you know what, I can zoom in, see? So 2, okay. So it goes into natural numbers. So there we go. Okay, 2 is done, so let me just cross that out. Okay, there we go. So now let's say -4. What is -4? Well, -4 is a rational number because it can be expressed as -4 over 1. It is an integer because it's all numbers, including positive and negative whole numbers. And it's a whole number. No, actually, it's not a whole number because it's all from 0 and up. So if it's -4, it is a rational number. I mean, it's a real number out here, and it's a rational number. It's an integer, but that's it. So let's classify -4 in here. So -4 is a rational number. No, it's an integer. I mean, so let me just get rid of that. It's a integer. It is a rational number. So let's cross that out. Now 20. So 20 is a real number. It is a rational number because it can be expressed as 20 over 1 or 40 over 2 or something like that, right? So it is an integer because it's all whole numbers, including positive and negative. It is a whole number, which is above 0, everything above 0, and it is a natural number, so because it's above 1. So let me just zoom in there. So let me just cover that like that. So 20, 2, 0. There we go. It's small. So, oops. Okay, so now okay, so that's canceled. So that, and then 1/4. 1/4 is a rational number. It's a real number. It's a rational number. But that's about it. So one, oops, too big. Oops, what am I doing? 1/4. Okay, there we go. Done. Negative 9/3. Now, you might be tempted to say it's a rational number. That is true. It is a rational number, but it is also an integer. Why? Because negative 9/3, you can simplify this so it's negative 1/3. No, 3/1, and 3/1 is exactly the same as negative 3, right? So it's an integer. So negative 9/3. Oops, I went into the whole numbers. Oops. So now we have, so that's done. Now we have, cross it out. Okay, fine. So now we have negative square root of 5. The square root of 5 is a real number. It is an irrational number because it cannot be. So this is the first time seeing an irrational number. It is a number that cannot be written as a simple fraction because the decimal just goes on forever without repeating. A cousin of square root of 5 is square root of 3, square root of 2, square root of 20, square root of negative 3, square root of 1,000,000, I think, square root of 6, square root of 7, square root of 8, square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15, square root of 17, square root of 18, square root of 19, square root of 20, square root of 1,000,001, square root of 1,000,002, and square root of 1,000,003, square root of 1,000,004, square root of 2,026, square root of 2,027, square root of 2,028, square root of what was it? No, it was the square root of 2,527. Or square root of, I forgot. Okay, anyway, so those are the cousins, and so here's a square root of 5. Okay. Now, again, pi is also a cousin of square root of 5. Okay, now here comes the last one. So it's 2 and this I symbol plus 1. Now, you may not recognize this number. This is an imaginary number because it contains this I. I'm not going to go over it a lot in this video, but just trust me, it's a imaginary number. So 2I plus 1 goes in the imaginary section. And that's it. So actually, here's another challenge. So you know that pi, so let me just try and get a pi symbol here. So you know that pi is an irrational number. What about pi over pi? So this one is actually really, really easy to solve. Do you know it yet? under a few, if you're not big high enough grade, you might not. But this pi over pi is exactly the same as so pi over pi is exactly the same as pi times 2 times pi times 2. 2 over 2, 1 over 1. So this pi over pi is actually equal to 1. So actually, pi over pi goes in the natural numbers. Pi over pi. I'm just doing a bunch of random scribbles. Let's see what I drew there. Uh-oh, we're zooming in the wrong spot. Oh no! Okay, whatever. So there we go. That is pi over pi. Erase. You know what? There's a better tool. I guess I'll see. Wait, I have to zoom out for this. Wait, what am I doing? Never mind. Okay, I guess I'll see you at how to do stuff with Ethan.com, and see you next time. Well, I guess that's a bit too gray. So, let me just do that again. Okay, that's a bit too light. Okay, whatever. See you at how to do stuff with Ethan.com, and see you next time. Yep, see you next time. Bye.